Welcome to the GOTO Podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello and welcome to another edition of the GOTO Book Club, and today I'm joined by Frances Buontempo. I'm Matt Godbolt, but Fran, why don't you introduce yourself?
Well, where do you even start? Hi, I'm Fran. I can't pronounce my surname properly, but no one can. It's Italian, so
Did I pronounce it wrong?
It's close. I think it's Buontempo, but my family has always ignored it.
It means like good time or something like that. That's a really interesting last name.
The equivalent English surname might be Fairweather, because translating human languages is tricksy.
But
I'm not a linguist. I did maths and philosophy at university and then got into programming computers, and here we are.
So we're talking to you today about your book. Do you want to talk us through what the book is and, a little bit about it?
So I published a book with Manning. It came out last year. It's called Learn C++ by Example. But between you and me, it might have been better being called Relearn C++ by Example, because I've aimed it at people who knew C++, but maybe lost track since C++ 11 or some of the newer features. So I've assumed that you knew something once, but don't know.
Or maybe you took a course at university or something. It's familiar. You're not like teaching programming from the beginning.
Exactly. Yeah. So, and I try to keep it really short. So it's about 225 pages. So I've only picked one or two salient bits that hopefully are quite common use cases and ways that some modern C++ actually simplified things. So
wow. I mean, I hear a lot about how complicated C++ is these days. For those people who are watching, maybe haven't even seen C++ for like 15, 20 years since they graduated or whatever. What is different? Why would you need a book to relearn it?
I think there are quite a few little bits of helpful syntactic sugar, which is really hard to look up. Magic things like the spaceship operator, which is like less than equals greater than sign. And the thing about punctuation is it's quite hard to search for in your favourite search engine.
You can't search for it, right.
So I've introduced some tools, including a famous online compiler explorer named after
I've heard of it.
Yourself. Yes, we're aware of that. And CPP Insights as well, which unpacks what the things might mean. So things like spaceship operators going to give you comparison operators for free for your types. And that's really handy if you want to use a standard map and you want one struct to be less than or greater than, that kind of thing.
Right, because C++ lets you override all these things, but it's complicated about 12 ways to do everything. And
exactly.
This is a simplification, but it ultimately is the same as all of the other things, or close to being the same as doing it all yourself.
Almost certainly going to come out with the boilerplate that you would have come out with. But unlike AI stuff at the moment, it will come out with the correct thing.
Right.
Most of the time. And there are other little things like structure binding, so you could unpack the first and second thing that you get back when you look things up in a map, so you can see what the key and value are and give them names. So nice little features that mean that there's less code for you to stare at and scratch your head over. But being C++, of course, it's then brought in loads more bigger, complicated things like coroutines and similar. That gives you more powerful things you can do, and they're quite hard to get the hang of. So hopefully I've covered some simple things in the book and then faced one or two of the harder things like coroutines. I think was the biggest, newest thing in there.
Right, I was going to say, that's, of all my experiences with writing C++, I've avoided coroutines. I mean, I've read the book and I looked at it and I thought, this sounds useful. I haven't quite found the right spot for it in my own code yet, but I think it's kind of impressive to try and attack something as complicated as coroutines in a relatively small book. I mean, 200 pages is still a decent amount, but you cover a lot of things, but you sort of got a broad set of topics, and then hopefully enough to get people interested.
I tried to find some simple things that make your life easier and then help you face one or two more complicated things. I mentioned as we were chatting before we started recording this, I'd come back from meeting C++ in Berlin the other week.
Which I believe you keynoted.
Yes, I did.
How did it go?
I was terrified. I'm still getting over it at the moment, but I got loads of questions afterwards, kept it all quite high level. I was talking about learning and teaching, and then delved into bits of machine learning and AI as well. So me being me, I just threw
learning
out
and learning. So learning for humans and learning for the computer.
And what does learning mean? And how do you know when you've learned something? How do you teach people things? Lots of big questions. Well, what I was going to say was Ivan Kuchik did quite a short talk, which should be on YouTube at some point, going through about 4 or 5 or 6 examples of maybe abusing coroutines might be the right word for it. And some of that was quite amusing, and some of it, well, you could see how actually you could kind of come out with some magic things there if you put your mind to it. So not necessarily, it was all quite, this is ridiculous, don't do this in production code, but look. And I went, ooh, on several occasions.
Well, so much of what I've come to know as sort of modern C++, I think, started out as, hey, look, we can do this cool thing in the language. And everyone's like, we never expected you to be able to do this. And then ultimately that becomes the way to do things. So it's good to explore the space.
Yeah, I mean, that things like template metaprogramming made everyone go, woo! And Herb Sutter and others have been talking about when we've got reflection working, goodness knows what we'll end up doing. So exciting times.
Right, there's a lot. I mean, for those who don't necessarily keep up with C++, C++ has changed an awful lot in even the last 15, 16 years, right? And so it's useful to have a book that you can go to. And as you say, if you have a little bit of experience of even C, right, you could probably pick up some of the C++y bits of it. Yeah. It's useful to sort of have an exposition of all the things you can do in C++. And it's not as bad as it used to be. It's the kind of feel for a lot.
Yeah, some things are definitely easier and simpler. Like you can just output what's in a vector without having to understand what all the different types of iterators are. Just some things are simpler. Right.
And talking about teaching and learning, you have a particular style of teaching, I've noticed in the years that I've bumped into you in conferences and reading your book and whatnot. So how would you best describe your approach to teaching?
I think if you can come out with some self-contained examples that allow people to just hold it in their head for a bit and play with the ideas, that's good. So I tried in this Manning book to come out with 8 different chapters after the intro chapter that were little games you could play afterwards, just like high-low, a card game or a slot machine game. So then you can play with it and go, can I give myself more lives? Can I constrain this? What happens if I do this? I learned to program computers by typing in the source code onto my dad's BBC machine, and I wanted to beat my sister at Pac-Man and asteroids and all the rest. So I found where the number of lives were in the code and changed it. I went, I've got 99 lives now. And that was my into starting to look up what all these weird instructions meant. And here I am, and here you are. Playing games, just engages some people better. Right,
and to have, as you say, a self-contained example, it means you don't have to hold this huge, framework in memory, in your own head and all that. You can sort of just look at a couple of pages, 3 or 4 pages of code and kind of go, maybe not even that much. Yeah. And sort of be able to almost follow it on the paper and go, oh yeah, I see what that is. I can print it out and I can understand it, or I can type it in, as you say, or you can download it. I think you've got a GitHub, right, for all the actual code. So we don't actually have to type it in. Although there's something maybe to be said for the act of actually doing the typing might, for some people, work it into their head a bit better.
Yeah, helps you remember when you do that. But yeah, definitely playing with stuff. And my dad, I said this at the keynote in Berlin the other week, my dad was a maths teacher and ended up working at a teacher training college. So he put a lot of time into thinking about how to teach people how to teach.
He's meta-teaching, teaching teachers.
Exactly. One of his main points was if you can get people to argue, that usually works. So if you come out with something surprising or counterintuitive, and someone goes, no, that can't be right, and I'll show you why, and then goes, whoa!
I think, isn't there an XKCD about this? You know, in order to find something, you post the wrong answer on the internet, and then you have everyone tell you why you're wrong.
Which always works. Yeah, but things with games give you that opportunity to go, oh, hang on, what happens if I jump into hyperspace? Or add some jokers to a deck of cards, and how do I even code that up? So it just gives you possibilities. Right. A lot of reference books are great and really well written, but because their focus is as a reference book, they've come out with quite terse examples that have usually got foos or widgets in or something, which is great and it's good for looking things up. But the internet, Reddit and all the rest is littered with people going, I want to learn more, suggest some projects for me to play with. And just simple things like high-low, a card game or something like that's a really good place to start.
No, absolutely. I think it's a fantastic way. I mean, to be able to put something into context and see it being used in a way that is approachable and is not covered with so much other complexity. I mean, especially in a language like C++, which, you know, like obviously you're trying your best to show it in a good light. But we've all, as professional C++ programmers, we've all looked at code and been like, oh my gosh, this is a 2-year project to understand what on earth is going on here, and it's going to have all these things that happen. Yeah, so to be able to focus on something,
even stuff like the spaceship operator, you start budging up against strict weak orderings and some quite mathematical concepts really quickly because C++ lets you be that precise. So
and I think, you know, that's a mixed blessing, right? You know, it's obviously you can phrase everything in it. You know, ultimately you can throw away all that stuff. You can write C, which is barely above assembly language in my view. But it also scales all the way up to these very highfalutin, you know, meta ideas and approaches, concepts, and as you say, coroutines, although coroutines is kind of a funny one because it's almost more machine-y than anything else. The idea that you can run two programs kind of and have them switch back and forth inside your own program is interesting. Although, so if I remember rightly, the coroutines example you show is a generator. Is that what it is? It's been a while.
So, I did a little example showing the generator then, which was just as a experimental version in some compilers. So you can do the equivalent of Python's just yield something for infinite if you want. But then I subverted the guess what comes next example that I was playing with. Where you do heads or tails and the machine's going to guess what you're going to predict based on the state of the last few things. And I just gratuitously wrapped it in a coroutine. So absolutely no point in doing that. I've just showed you how to do it. I don't know. Quicker, but
but coroutines aren't necessarily a performance thing or a faster to program or anything. Again, it's more of the but. You've got to try and find an example that speaks to people and rather than try a new example that people are going to wrap their heads around and introduce a completely new and somewhat alien, especially to sort of more systems programming people, concepts of sort of high level function. You can call this function and it can stop halfway through and give you a number. You're like, wait a second, but you know, that kind of stuff. It makes sense to use something.
I just tried to keep things simpler there. Now a lot more compilers are supporting standard generator fully. Nico Jassusis was talking again in Berlin the other week about some examples, and he came out with some really cool things where you can, if you just yield results at certain points, you've kind of got a state machine, but then you aren't having to lark around with lots of ifs and elses to deal with the state changing, and the code ends up being much neater and you don't have all the edge cases dealt with switches or ifs and elses. So there are some ways it can make your code easier to reason about and read. Right.
Though if I remember rightly, the thing that I found difficult about coroutines is there's a lot of sort of magic machinery that you kind of have to boilerplate in a bit still. It's sort of relatively new and there's not I mean, std generator is different obviously because that kind of comes with the compiler and it looks like, as you say, Python.
Yeah, whereas writing a coroutine from scratch is you kind of like a kit car in front of you and you've got to find all the bits and piece them together. It's not straightforward, but loads of people have given talks about it and walk you through how to build one. But if you don't want the details, fine, just play with standard generator instead.
Right, which is, I mean, that's even valuable, right? You know, we've all, I mean, especially if you dabble, and I don't know of any C++ programmer, serious C++ programmer who doesn't dabble in Python on the side just to kind of like hold everything together. That's a kind of like the glue language that we've all kind of adopted. You've probably used generator style things with your yield and that kind of stuff. So you probably know the concept, and it's easy to write those things, and they're very convenient sometimes, as you say, kind of builds the state machine for you. It's great, you know. So talking a little bit about styles things, I noticed that in the book, you kind of go for what has become known as almost always auto sort of style. What are your thoughts about that? You know, it's sort of contentious among some people. They don't like it. And so why did you go this way?
I thought it was worth at least presenting it because quite a few people do use it. There are obviously some edge cases where you get in trouble, like if you use an initializer list, that's what you've got, right? And that might not be what you mean. So sometimes explicit is better than implicit. There are obviously cases if you're using a lambda where you want to keep it an auto, otherwise it's going to end up in a standard function or something else that's less efficient.
Yeah.
I find it much easier to sit on the fence and always see both sides of an argument. it seems worth introducing that, and I don't think I've done auto everywhere through the book. I do sometimes state the type of the thing I'm declaring. But I think it's worth knowing about because a lot of people use it. There are obviously some gotchas because this is C++.
I mean, everything is a gotcha in C++. That's unfortunately part of the territory a little bit, but yeah.
Yeah, but that's why we like learning C++. I think some people off-put because they go, whoa, it's too big. If you can pick your way through it and just get the hang of the basics, that's really useful. I've seen
you mean C++ itself, you mean?
Just get the hang of it, even if you think it's hard. I've seen a lot of anecdotal evidence about people who, if as a student or even a junior programmer do a bit of C++, then they find other languages much easier.
Interesting, because they've done it on hard mode once.
Yeah.
But I think, you know, the difference is if you've done C++, which is, despite the standard library and despite a lot of things, it's kind of batteries not included. You're exposed to everything and all the entire design space is open to you, and you kind of have to make your own decisions about which things make sense for you. And then you go to a more opinionated language. You're like, well, okay, it's my way or the highway. If Guido van Roofsen hasn't decided this is a good idea, I mean, that's a bit old now, but whatever, you know, then you don't get to do it. And maybe you'll get a little bit more of like, I wish I could do this. And in C++, you can. You just have to unfortunately pay to do it, right? Yeah. So maybe there's a bit of that in there.
Yeah.
But also it's an interesting one. Sorry, I just brought that up because it's something that I still argue with people about. And for those who are not listening, auto is those who are not listening, those who don't know what auto is, it's sort of like it lets you tell the compiler, you work out what type goes here. Yeah. A bit like let in many other languages or var in others that just say, hey, it's a variable, except it's still strongly typed because whatever you've got on the right hand side, it kind of infers. And the only thing is if it infers it right, fantastic. And it saves you writing std iterator of some complicated thing. But if it infers it wrong, then you might be copying a giant array every single time you're iterating. Yeah. That's the kind of gotchas you were referring to, right?
Yeah, then you need to watch out if you've got R-value references going on and all kinds of things. So, and
do you talk about that kind of stuff in the book? I don't remember seeing it explicitly because, again, that's on that sort of math theoretical side of the language where, you know, you took your PR value from your X value from your, you know.
I didn't go as far as PR values and X values and all the rest of it, but I did talk about L values and R values and standard move, just enough to let you know that's kind of what it's doing, and here's more details.
Right. Again, you don't want to put people off. You want to give them the tools that let them understand the program that you're writing. And if you're using, I don't know, I think you did smart pointers. If you've used unique pointer, you're going to have to learn about std move if you want to like push it. Yeah. Transfer it around and things like that. So you need to just enough to be able to say, these things exist. If you want to treatise on not type theory, what is it? Category theory. You have to go and look it up a little bit. But I mean, I'm someone who has to look this up every single time. It's something that I should probably put on the side of a mug and have on my desk rather than me, you know, so, but pragmatically, you learn the patterns that make sense for your use cases, and then.
So I did an introduction to classes, and compared to like C++ 98, now you've got moves, and you can enable or disable copies or default things. You have to consult Howard Hinnett's table about which ones cause what to happen, and I have to look it up each time. I know Herb Sutter and others have been trying to play around with meta classes to get things that actually generate some of the boilerplate for us automatically, which, and I said this at my keynote the other week, please, we need more of this and less of that AI generating things that is slightly wrong. If you're stuck, look it up or find a way to generate the code for you that's correct. But yeah, there's a lot to remember in C++, and doing OOP in C++ is harder than it was, but you can be more precise than you used to be. So pros and cons.
Right. And I suppose so you're talking about the kind of things that Herb's looking at for the future, that sort of C++ 26 and beyond. So C++ comes up with a new standard every 3 years, and the latest, greatest gets pushed into it. It coming in C++ 26 is the beginnings of reflection, static compile time reflection, where you can ask, what does this thing let you do? And then Herb's ideas are then using that for generation to be able to sort of use the reflection, the power that it gives you to then say, look, if I want a non-copyable class, I will say it as a non-copyable class by saying some magical annotation that can reflect, and it's all written in C++ as well, which I think is a nice way of, writing it. But so, I mean, the obvious question from that is, will there be an update to the book for C++ 26?
Down to the publishers. Perhaps I ought to have a chat with them at some point. I am in the middle of writing another book at the moment, though, so let's not stretch myself too thin.
Oh my gosh!
So
I mean,
the one I'm writing. The one I'm writing at the moment is an introduction to C++. So it's for people who don't know it at all, which is far too hard. I don't know why I volunteered to do this. Oh my goodness! But nearly there.
Wow. I was going to say, there's a lot. I mean, we sort of glossed over that by sort of saying your recurrent book is like, assume that you've got some working familiarity with it. And like just the idea of explaining pointers and references from like the ground up, it sounds challenging.
Yes. The phrase constant variable caused some pause from my editor. I was like, why am I doing this? But yeah, we got there.
It's like a live recording, isn't it? It's an it's an auto oxymoron or whatever, something like that. Something that's like self-contradicting in 2 words. But yeah, so obviously writing books is something you enjoy doing. And I believe you're not the only person even in your own household that writes books. So, is it just thinking about teaching and learning is something that just goes on around you? And obviously you're from your family background as well, that seems like it's been part of you.
I guess I've just ended up here. My dad wrote a book about maths once. Actually, that's probably why I've ended up here. He'd written one book about maths years ago when I was like 5 years old. Oh, my dad's written a book. My dad's famous. And he went, I've earned 2p per book I've sold, and I've earned about £2.50 so far. This was back in the 70s.
That was a lot of money in the 70s. That's two type-in games or two cassette games.
Indeed. But so he died a little while ago, over 10 years ago, and he'd started writing a second book. And I kind of thought, perhaps I ought to try and carry that for him and actually get it published. But it was in 3 or 4 different places. I couldn't work out which was the most recent one, because he'd got feedback on one thing, but then written something else. And I just looked at it and went, this is going to take months. And there's some bits he's not covered yet. And it was about geometry. Now, I've got a maths background. I've got a book on category theory. I can understand it. I like this kind of stuff. But there were some gaps in my knowledge, and I thought, I can't do this. This is ridiculous. And by that point, I'd given a few talks at ACU and some other conferences. I thought, I know what, perhaps I'll write my own book first and then see if I've got the bandwidth afterwards.
So that's how you got into writing books, is that you kind of like, you thought it would be a warm-up for resurrecting your dad's book.
Yeah, kind of, and now I don't even know where the hard drive is, where his stuff was, and like, that's not happening. So it was an accident. When I was at school, I was in the bottom class for reading and writing things. I was really good at maths, but I struggled to spell, struggle to speak properly, but I'm from Kent and we pronounce things wrongly, and I think you're from
I didn't want to say.
You're from that sort of direction. I can't hear the difference between 3 and 3 because it just sounds the same in my head because of how people talk right there. It's just a thing. But I ended up editing the Overload magazine for AtQ, and that means I've got a review team who go, Fran, you've done it again, but they correct my typos and things, and I've learned that there's some things I can't do that I need help with, and that's okay. Right. You just need to find the right kind of help that you can do things that you did not think you'd be able to do at all, ever, which is amazing.
That's, yeah, fantastic. And to be able to, as you say, carry on the tradition for somebody who finds that thing quite difficult to do, it lets your character, because I think you've got great ideas. And actually, talking of those ideas, one of the things I always think of when I think of you is your X out of a Y bag series of talks. And I think, is there an example in the book even, I think? Is there one of the ones that's...
We race our way out.
How did you get to that as being a sort of teaching device?
So the book's got an example of racing your way out of a paper bag. So you set off some classes that move in different ways. One might just do one step at a time. One might take a random integer step. One might take a floating point step. So that gives you the OO thing. And then just see who gets up the top of the screen first with an imaginary paper bag drawn around it. Bosh.
I see, because, yeah.
How did I get here?
Yeah.
When I was contracting an investment bank in London years ago, used to conduct interviews periodically with another colleague. We came out of an interview and my colleague said to me, that guy couldn't even code his way out of a paper bag, which is a silly throwaway phrase. But I go slightly autistic and literal about something. So I was going to say, well, what do you mean? How would you even do that? And then I stopped myself and thought, yeah, shush, Fran, okay, just let
this
the
is
other
a good
guy
idea.
talk.
Put this in the ideas jar.
And it just wouldn't stop. And I kept going, whoa, I could do this or I could do that. So I got a few talks out of it. And actually, once you've got a kind of go-to place to play with things, it's quite a good way of playing around with a lot of machine learning algorithms and things, and allows you to visualize how things move and change. So here we are.
And it's sort of, again, it dovetails into your preferred way of giving people practical examples of things while being relatively simple and self-contained. You can draw a little bag on screen and you can say like, okay, we've got to teach the little dot to get out of the bag and we give it a reward when it gets out the top. And then we do reinforcement learning, or we do some other clever thing that, I haven't thought of on the spur at the moment, I'm sure. But, that's just your approach to teaching, is it's got to be something that you can hold in your head and simple enough to I've lost most of the train of thought now. Simple enough to hold in one. Yeah, go on.
Yeah, if you can come out with something that you can demo in 1 hour, then you've got a talk for a conference for starters. And also, if you come out with a smaller example, as sometimes it takes weeks to pare things down to the simplest possible example, then I can go for a walk and still have it in my head and think about it. And sometimes it's good to step away from the keyboard and be able to think about something. Otherwise, you dig deep holes for yourself, which is the opposite of getting out of a paper bag, I think.
It's like, well, that's fantastic. I mean, it works for me as well. I love seeing the practical examples, and the sillier the better. They're memorable. Of course. They stick in your head. And the same with all of the examples in the book, right? You've got some fun little games in there that are, almost worth typing in. Just have a play around with them, even if you do know what you're doing.
Yes.
And I don't think any of us really know what we're doing, honestly. I mean, speaking as a professional C++ developer, I still struggle. And I find books like yours really a valuable thing because, it's a huge language.
Yeah.
And just flicking through and going, oh, I'd forgotten that you can do that. I didn't realize you could try in place, and then it gives me a thing or whatever. You got to, and then it just goes into the back of your mind, and it's another valuable thing to add to your day job. In my case, yeah. Just
a few little clues and little bits. But like you said, fun. That's important.
No, absolutely. Well, where can we find you online if we want to learn more about your approach to teaching?
So I've got a blog which has got which I don't post on regularly, but I've got some overviews of the chapters in there, so you can see what a card
so people can take a look on your blog and have an idea about what it is, and then and then if they want to buy your book, I'm sure they can find it. We'll post it in the description or whatever of this chat.
I do hang out on LinkedIn and Blue Sky and various other places from time to time, so I'll share some links that we can put up after this.
Fantastic. Well, it's been an absolute pleasure chatting to you, Fran. I've really enjoyed it, and I encourage folks to go and check out your book.
Thanks for chatting to me.
Thanks for listening to this episode of the GoTo Podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.